Gentlemen, good evening, sir. Ladies and gentlemen, welcome to HMS Sultan. Can I start the evening by thanking HMS Sultan's Executive Captain, Captain Deacon, for allowing us to host the Royal Naval's annual RENA and IMRS Southern Joint Branch Technical Lecture. I've been informed by Lizzie that it's the RENA/IMRS, and not IMRS/RENA, so we know where we stand. In here, the recently upgraded Dreadnought Theatre. It's good to be back. I know the numbers are short, coming out of COVID and everything, but it's good to have faces back in the audience and good to have people meeting again coming out of COVID. So thank you for coming along. I'm just going to run you through, firstly, who I am, why I'm here, and I'll hand you over to Chris. Can you hear me? I'm aware I keep moving it. And we'll do some health and safety introductions, some domestics, and we'll move on from there. Okay. So good evening, 1 Officer 2 Mid-Jure. I reside within HMS Sultan now as a lodger unit, having spent many years instructing and managing within Rutherford Block in the Submarine Training School. I currently work for the Royal Naval Submarine Training Centre project team as the Assistant Requirements Manager, and I'm involved in the forthcoming move of MESM training, and that's everything from ME submarine pipeline and trade-specific training, as well as the training assets, the people and everything that goes with that, up to the new purpose-built RNSTC facility up on the Clyde. I'm not sure if anybody's. Has anyone heard of the plans to do so? You have. Yeah, that's an exciting project that will be happening over the next few years. So that's a little bit about me. I'll just be introducing Chris, but firstly, some health and safety. There are no plans for any fires or evacuations. Quite clearly, the fire exits are located at the front either side of you, and there's one to the rear. If we need to evacuate, follow the personnel in the white uniforms. We are well versed in doing this. We know where to go out in the car park. We've got a guest list. We'll take people off and we'll make sure we're safe. Happy with that? Like I say, there's no plan for any alarms tonight, so if there are, just listen in. Toilets, feel free to just go to the toilet if you need to, out through the double doors, turn left, through another set of double doors, and the ladies and gents are positioned on the left and right hand side. Left and right hand side, first doors. So not too far. Like I said, I've got many years of experience with something, so anything that does happen, we should be able to cope with it reasonably well. So, Dreadnought Theatre. Dreadnought, the name, it conjures up, certainly to me, and possibly many of you in the audience, images of past naval glory, hulking great battleships from the early 1900s. The 1904 battleship HMS Dreadnought revolutionised naval firepower and changed the speed at which we could operate. So much so that everything before the Dreadnought was called exactly that, pre-Dreadnought. It brought around a series of battleships that certainly lived up to the name. Then we have the UK's first nuclear-powered submarine, HMS Dreadnought, built in Barrow in 1960. And certainly that started off the nuclear fleet that we hold dear to us today. And if you weren't already aware, it's the Dreadnought is the name given to the current Trident-class submarine replacement, and the project that's going to see that replaced with a 17,000-ton Dreadnought class brought into service early next decade. The HMS Dreadnought, as is a standard convention, being named as the first of class. Anyway, on to this evening's lecture. I don't want to steal any of Chris's sandwiches here, so just give a brief overview of what I think the Carrier Strike Group 21 is. And that's mostly taken from Wikipedia and the internet, so it's probably wrong, as well as what I like to call something called Navy by numbers. Okay, do a lot of STEM up with children. It's a way of engaging children. Quite a lot of numbers and stats at them, and they tend to soak some of it up. So we'll see if there's any young minds in the audience. Carrier Strike Group 21 deployed an engineering support that ensured a hugely successful trip. The purpose of which I see was to project not only our naval capability and firepower, but hopefully our diplomacy and great name across the globe. And firstly, we need to appreciate what that carrier strike group is. Now, to me, it's made up of the following: fast jets, helicopters, destroyers, frigates, nuclear submarines, support vessels and minesweepers. They're all vital assets, each with their own individual role to play in the modern Navy. But then put them together with a state-of-the-art aircraft carrier, namely either Queen Elizabeth or the Prince of Wales. Slap that bang in the centre of them, and we have something that resembles a fighting force that's not just potent, but it's also flexible. Carrier Strike Group 21 by numbers. This is the bit I throw out to the kids. Chris might disagree with me in a minute. They were away for approximately 244 days. And as a submariner, that's quite short. For us, that's quite a short period of time, but we won't go there. The group travelled across the globe, spanning approximately 50,000 nautical miles. Again, you might contradict that in a minute. This is my insight into it from Wikipedia. Made visits to over 42 nations and 3 different independent territories, representing 47% of the world's population. So you can see the reach that they had there. And that encompassed 53% of the UK's trading partners. There was media coverage of the group's activities in 99 countries and translated in 252 different languages. The group hosted 66 government ministers, 106 ambassadors, and around 500 senior officers from foreign militaries. It's quite a large-scale mission, to be fair. Now, this is a bit that I said the kids would love. Crucially, the MOD states on their website that the 3,700 personnel who deployed with Carrier Strike Group, they enjoyed and they consumed 25.5 tons of sausages while away, 190,000 potatoes, and 2.01 million eggs. Is that right? HMS Defender alone got through 55,000 sausages, whilst HMS Kent consumed only 13,000. Such details may seem frivolous, but they do give an insight into the considerable logistical challenge of sustaining a naval force at distance. And that's probably the easy part, as hopefully you might find out, feeding people whilst they're away. I'll shortly hand you over to Chris, who's going to present his lecture on how they met those engineering challenges. But one last thing before I do hand over. It's a signal that was sent out prior, I think, on the eve of them sailing for the Carrier Strike Group, from CTG, and it read, "From where we sail, generations of men and women have left these shores to serve the country in peace and war. Tonight we follow in their wake. We are privileged, we are humbled to be joined in this endeavour by our American and Dutch allies. In due course, we will be joined by other partners too, like-minded nations working together to strengthen the rules and the freedoms upon which our shared security and prosperity depend. While the scale and complexity of this enterprise may seem daunting, I have confidence in you. Over the past few months, you have transformed a collection of individual ships and squadrons into a cohesive fighting force. A force that is now ready to represent Britain and NATO on the global stage." This is a bit I find interesting. Not everything will go to plan. It rarely does, but our individual and collective training to date has been preparation for this moment, and through your skill and your commitment, you have what it takes to adapt and overcome. So my most important instruction to you is a simple one. Understand your role, your duty, do it to the best of your ability, and trust those around you to do the same. Follow this mantra, and we will surely succeed. You remember being that? Do you remember that being read out? You probably not to hear it. Okay, I will now hand you over to HMS Queen Elizabeth Senior Marine Engineering Watchkeeper Lieutenant Chris Mullen to talk us through his presentation.
Right. Does this work? I might need that one. Testing comms. Is it on that?
Just push it in the middle.
Hello?
Here you go.
Hello.
There we
Now you can control the volume.
Okay.
Right, they say you should never start a presentation with an apology, so I won't, but I'm going to stand here so I can use the mic and do the laptop thing. That's a photo of me on the flight deck of Queen Elizabeth. I did the whole trip, and I will spin you a quick bit on how it went from my point of view, the successes and the challenges that we faced whilst away. So I'll briefly talk about what carrier strike is, bearing in mind Mitch has already stolen my sandwiches, what carrier strike does, what CSG-21, also known as Op Fortis, what that actually looked like in the end, then the interesting engineering bit, the challenges we had and the successes that we had, and then some of the key lessons from my point of view that we need to learn if we're going to do this again and do it better. So what is Carrier Strike Group? It is enacting government's policy that we should have a global navy for global Britain. Maritime Strategy 2035 states that the Royal Navy will deliver a carrier-centred carrier strike group, including sufficient support shipping capable of operating at least 24 UK F-35 Bravos by 2025 to deliver carrier strike. One carrier is planned to be available 100% of the time, either at sea or alongside very high readiness to deploy. The carrier strike capability will be planned to maintain very high readiness or deployed at all times to at least 2050. So, not much of a challenge there. So this is what CSG-21 actually ended up looking like. It is a Queen Elizabeth class carrier accompanied on operations as part of a strike group of ships, submarines and aircraft, offering a network of defensive and offensive military capabilities. The strike group can move, act and fight as a single cohesive force, even when spread out across thousands of miles. But, and we did this, individual ships are able to detach from the main group to conduct independent or concurrent tasks as required. So we said, for example, Defender and the Everton off to the Black Sea while we proceeded through the Suez Canal. While the carrier strike group can incorporate ships and aircraft from partner nations, and I'll talk about that later, it has a sovereign British core consisting of the following units. Queen Elizabeth class aircraft carrier, the centrepiece of the carrier strike group. Queen Elizabeth and her sister ship Prince of Wales are the largest vessels ever built for the Royal Navy, and they are the first and only aircraft carriers in the world designed to operate 5th generation strike fighters. We've got the Type 45 air defence destroyers, the Daring class Type 45 destroyers protect the strike group from enemy aircraft, missiles and other airborne threats using their Samson radar and Sea Viper missiles. The Type 23 anti-submarine frigates, whose primary role is to be super quiet, to hunt the enemy submarines using a towed array sonar, and Merlin Mark II helicopters. We have a submarine. The carrier strike group routinely includes a Royal Navy nuclear-powered submarine armed with Spearfish torpedoes and Tomahawk land attack missiles. And they're ideally suited for gathering intelligence and sanitizing the area before the main carrier strike group enters. Then we have the Tide class tanker, a fast fleet tanker operated by the Royal Fleet Auxiliary accompanying the strike group to provide the carrier and her escorts with diesel, aviation fuel and fresh water. And we did take all three of those at the same time, following a few issues. And then we have RFA Fort Victoria. So the Fort Vic, she was a replenishment ship. She struggled along with us the whole way, supplying us with fuel, more importantly, stores and food, spare parts and ammunition, including precision-guided munitions used by the F-35s. She also has a large flight deck and hangar and carried 3 Merlin helicopters and a load of Royal Marines for sort of land-based strike capability. So on here, I'm just going to highlight two other vessels that we had. So we had the USS Sullivans, which is over on the far right, as I see it, and the Everton, which is next to her. That's an Arleigh Burke class destroyer, Arleigh Burke class frigate, and the Everton is a destroyer similar to a Type 45. So what was CSG's mission? Well, it was to provide carrier strike to prove carrier strike initial operating capability. Her Majesty's government had 4 objectives: to deliver multi-domain operations across various areas and under various frameworks, to be NATO's leading European ally, to prove UK-US interoperability with the F-35 and with the Sullivans, and to influence the global audience through defence engagement, particularly in the Indo-Pacific, through media and strategic communication, and to promote UK trade and prosperity. Think selling carriers and Rolls-Royces to other nations. But for me, this was what our mission was as engineers: to generate and deploy, to sustain, recover, and to prove the initial operating concept for the N4 function, which in military speak is logistics. And that includes the group repair coordinator and the group logistics coordinator, key functions that don't normally exist outside of a task group. So when ships are by themselves, we don't have GRCs and GLCs. For me, the key takeaway was the sustain point. That was going to be key to our success. However, it wasn't lost on me that the challenges we were faced would be the scale, the reach, COVID, and the time that we're going to be out there. So I'll expand slightly on the scale and the reach of Op Fortis. I think the other two are pretty self-explanatory, but pretty obvious challenges that we faced. So the scale. The task group consisted of 9 surface ships. That's not a small footprint. And my maths might be out here, but roughly 175,000 tons of naval surface shipping, which in one ship is probably not that big, but spread across 9 different platforms is a lot to look after. We had 450 megawatts of power in those ships available to our commanders. And bear in mind, 3,900 people, about 1,000 of those were engineers of various different flavours, marine weapon and air engineers. Being a marine engineer myself, I'll focus on that, and we are at Sultan after all. So the reach. There's a map of everything that we did. You can see that we spanned pretty much half the world, disaggregated at times with units up in the Black Sea, whilst other units were at the same time were operating in Red Sea and Indian Ocean. I think we made it to Guam before HMS Defender even managed to leave Toronto. So that's how spread out we were. So that's the reach that we had, whilst operating all as one unit under one command. Now the interesting bit, the challenges. So this is what we actually achieved. Early in Op Fortis, HMS Kent suffered a number of setbacks, including, I don't know how she managed to do it, but they put fuel in their freshwater tanks. And they had to, and they also at the same time, I believe, had a Rolls-Royce spade to change. Fortunately, the resource and expertise from HMN, from Clyde, up in Faz Lane, lent in and treated their freshwater system at short notice during the validation phase of the exercise. So right, pretty much day one, they managed to do this. It was led by the Type 23 class output management cell based in HMB Portsmouth, and for me was a prime example of wider UK PLC working together to achieve the aim for UK defence. The Royal Navy relied heavily on SMEs from Rolls-Royce and wider UK PLC, including BAE and Babcock, to support an emergent operational defect work whilst deployed. And this was tested again slightly later on when HMS Diamond suffered from high oil consumption in the Eastern Med, and were forced to change one of their Rolls-Royce WR21 modules in Toronto before they were allowed by our commander to proceed through the Suez Canal. Basically, the rate that they were drinking oil, they wouldn't have survived with us. So it was a forced decision. What we saw here was the work that's normally carried out by discrete comms or class output management cells, normally for each class of ship. They were coordinating resource at shore, and that was all, they worked together, formed a virtual comm across the dockyards and worked with their UK industry and suppliers to achieve this success. Just as important, the global presence of Royal Navy suppliers and their ability and willingness to support us around the world cannot be underestimated. In summary, Diamond would not have got off the wall in Toronto without the help of Rolls-Royce. Against the backdrop of COVID, the movement of stores and personnel wasn't always easy or possible, particularly once we were east of Suez. Royal Navy maintainers and engineers employed their typical can-do attitude alongside some ingenuity, some risk management, and the training that they received here to achieve complex and novel repairs and maintenance procedures to sustain their ships and aircraft. On the left, we've got a photograph of my wonderful maintainers on Queen Elizabeth working on the ship's pyrolysis plant. It's a relatively new piece of equipment in the Royal Navy. It's unique to capital ships, we don't have them anywhere else. And there's very few spares available. Indeed, the original manufacturer has gone bust. Coupled with that, there's no bespoke training on pyros at the moment. So it was a case of going back to first principles for us and understanding thermodynamics and chemistry, what happens when air gets into a place that there shouldn't be air and the fire escapes from the thing that sets everything on fire. The importance of understanding why and how equipment works and teaching engineering fundamentals in this instance cannot be underestimated. With 1,600 personnel embarked in Queen Elizabeth alone, sustainability was incredibly important, and having both pyros out of action really wasn't an option. Both Defender and Queen Elizabeth had 3D printers on board. They were used to produce parts and repair solutions that were otherwise unavailable. Queen Elizabeth and Defender produced plastic sleeves and collars to repair failed PVC pipework on RO plants. That's when we had to take fresh water on. A bit embarrassing. Tools for aircraft maintenance, as well as some more mundane items such as door holdbacks and some handles for phones. 3D printers were used quite a lot, and some of them are still in use today on various phones around Queen Elizabeth are red rather than black. The limitations of 3D printing were explored and will be built on. Components with fine tolerances or critical to safety can't be easily manufactured, and particularly in the world of aviation safety, will not be approved for use. These limitations and cultural issues are now understood, and as the technology improves, costs reduce, and confidence in designs and onboard manufacture builds, I see the use of 3D printing drastically reducing supply chains and improving sustainability in our surface ships. So, where are we going? So that said, we did challenge policy quite a lot. We would quite often not receive approval to use plastic parts or to do what we were doing. However, we could use the excuse of we were halfway around the world. It's our only option, and we took risk where we deemed it appropriate. There's no way we could have survived, for example, constantly taking fresh water from Fort Vic. We had no option. We looked at the pressures, for example, involved with the RO plant and decided that we'd give it a go. And it worked for about a week, which was enough. With all that time away, focused on the task and broadly spent at sea and not alongside, thanks to COVID, we saw ships training teams able to deliver in huge amounts. The RN has recently adopted the City and Guilds framework for apprentices, with a dedicated training senior rate in Queen Elizabeth. Process was pioneered and best practice was established for the wider fleet. Queen Elizabeth assessors contributed to the award of over 30 Level 2 Sitting Guilds Awards in marine engineering and the very first Level 3 award in the Royal Navy. Completion of these awards prepares our junior rates for their foundation degree from Portsmouth University on completion of their petty officers course. As well as their civilian qualifications, we awarded their military ones, so their MEF Swatch 1 and MEF Swatch 2 certificates. The numbers are up there, but that's broadly equivalent to, I believe, I did have it here, but I've lost my text, so I can't see it. But they do marry across to your MCA STCW qualifications. We also had the opportunity, with all that time at sea, and with a capital ship with huge workshops, we were able to provide skill at hand training for our ETs, so our very juniors, most junior maintainers. It's one of the skills that we found that they were lacking, especially with COVID. A lot of the workshops here were closed without instructors, for example, so we were able to provide them with that training in electrical and mechanical skills, woodworking, metalwork, brazing. We stripped down a two-stroke engine and put it back together. We found that brought on their skills and confidence and helped to inform them in their future careers, whether they want to go M1 and work on diesels and petrol engines, or whether they want to go and clear the toilets, for example. So I've already stated how important the UK-based global support was to sustaining the Carrier Strike Group. With COVID-19 marching on, the planned task group deployed support period in Japan and South Korea, so we were going to split off and go to respective very capable dockyards, was cancelled. With isolation requirements for contractors, military personnel and ships companies just one of the issues that we were going to face. The task group had clocked up by this point over 15,000 miles per platform, and a considerable planned and unplanned maintenance bill was now in our laps. Completion of DSP, or deployed support period, was not negotiable. Queen Elizabeth had aircraft lift issues with a potential failed lift bearing, with diesel fuel injection pumps which were failing pretty much every day. So with about a month's notice, we went to Guam. Those of you that have never heard of Guam, it's a tiny little island in the Pacific. It's not on most maps or globes, and its population is smaller than that of Portsmouth. It's roughly the population of Fairham. So we sent 9 surface ships with all that tonnage and power and all those problems to Guam to try and fix them in 2 weeks. And fix them we did. We used up all the island's resource. We had to sort of order in large cranes from America, ship them over. We had to divert 100 tons worth of stores to the task group last minute from Japan to Guam, and it met us there on the jetty. At the same time, it required the virtual comm, which consisted of the Type 23, the Type 45, QEC comm, to work together to book flights for Rolls-Royce, for various different contractors. Wartzilla is another one, to come out and meet us there. I don't know if it was luck or judgment, but thanks to the US airbase and the number of flights between Guam and the US, we were able to achieve our aim. We got our Lloyd surveys done, our pressure vessels tested and back in date. We had our pretty much every fuel pump on every engine replaced, and we were just about good enough to go again. So that flexibility and adaptability of the RN support partners to achieve the aim was vital. So that brings me on to the lessons identified. Despite our obvious successes as engineers on Fortis, it would be foolish to think that there was no room for improvement. Mistakes were made, weaknesses were identified, and some of the lessons we have identified must be learned to ensure that we continue to be successful and achieve full operational capability by 2025. Firstly, and in my opinion as a senior watchkeeper, the impact on personnel cannot be underestimated. No RN ship deployed with a full complement of engineers. We asked a lot of our people. We asked them to be away from their loved ones for 7 months, to see planned port visits go up in smoke across the Far Eastern Indian Ocean. They had a lack of connectivity and no Facebook. had to work many weeks at sea without against a busy operational tempo, supporting surface and air operations, and covering gaps at sea all took their toll. It's no surprise, and we all know as engineers in here, that globally there's a shortage of engineers, and if there's a better offer outside, people are going to take it. And that's something that we saw. We saw a third of our leading hands across the ME department on Queen Elizabeth put their notice in. So the lesson learned, or the lesson identified rather, is that we cannot underestimate the impact of these deployments, lack of spares, lack of support on our people. Which brings me on to spares and availability. The high profile defects always get spares and they're always available somehow. So when we had fuel injection pumps failing on diesels, it's pretty high profile. Wärtsilä got us the stores and we were able to change them. More importantly for me, on day one, when 1,000 people embarked on my ship, I couldn't have a hot shower. So shower mixers failed across the ship. They were going every day, and we couldn't get stores for love nor money. The only way that we could get the shower mixers we needed was to go send someone to Screwfix in the UK, empty them of shower mixers, put them on a flight to Cyprus, get them out to us. The lesson really is that the naval store system needs to improve for us to be able to do our jobs. It also has an impact on personnel if they can't have a hot shower, and on maintainers if they can't do the job that they're trained to do because they don't have the spares. We will learn the lesson, and I implore the Navy, wider Navy, and my superiors to analyse what we used, learn the lessons, make sure that they're on the shelves for next time. Another lesson identified was a potential over-reliance on OEM. I've already talked about Rolls-Royce coming out to a couple of ships. We had Wärtsilä come out to us in Guam, but they won't always be there, especially if there's bombs and bullets flying. A key thing that all these people flew out to us with was a laptop. It's important for the Royal Navy at the procurement stage to make sure that we buy the laptop and the software to properly equip our maintainers so they can use the spares when they're there and so that they can be basically employed correctly and therefore not leave the Navy. Finally, training. We found that a lot of training was out of date or didn't exist for equipment. We now know the defects we're going to have, and there's a lot of corporate knowledge currently within the Navy. Our job now is to capture that corporate knowledge, update our courses and train our people so that next time we go out the door, it won't take us 5 days to change a pyrolysis screw, it will take us 1. There's many other lessons identified and many of them are secret and strategic, but some of the tactical stuff, like just making sure there's shower mixers available, can't be underestimated. So what next? Well, Queen Elizabeth is still at very high readiness, despite all the scaffolding that's on the flight deck. If you look across the water, we're at 5 days' notice to go anywhere across the world for whatever mission we get given. We have our annual planned deployment up at Killian, sailing in September, and hopefully some of the lessons from Fortis will be learned and practiced along the way. And as we continue towards 2025 and FOC, it's, in my opinion, the most important thing we need to do is change those lessons that we've identified into lessons learned so that we can achieve FOC. So that concludes my presentation. If there's any questions, I'd love to answer them, be that across personnel training, operate, maintain, diagnose, or repair. I think Mitch wants to record it all.
Yeah, so I did my displacement pre-training on board our own ship.
Yeah.
Now I was just wondering about so I managed to print parts for an RO pad up to 80 parts. I wonder what kind of parts you guys were printing and how you coped with also bed leveling and stuff like that whilst you're away. With regards to warping whilst the ship was pitching rolling.
So the parts we were printing was, so we had failed pipe work, just with sort of cracks along the length. So we're printing collars essentially to wrap around the pipe work. That was the repair solution we came up with. We weren't able to 3D print huge pieces of pipe. We didn't have that size printer. And in terms of auto leveling, I don't know if you've been on QE, but it just doesn't move.
Yeah, a bit on Chris Mullen, but I was just curious whether you did it at sea or on.
Yeah, the RO plants, obviously they failed when we were at sea. So that happened when we were in the South China Seas. We weren't going alongside. You know, we were on the hairy edge. We razzed water from the Fort Vic. We were getting that low. We didn't actually tell anyone on board that we were having that problem, because the first thing they'll do is fill their water bottles and take a shower. So yeah, we didn't have any problems as far as I know with leveling. We printed loads of stuff. We even printed like little gizzets and little F-35s that people could take away. Yeah, no real issues. I think the only issue really is size and filament, and sort of printing the right material and having that on board. We just need to have it on board so that we can print the right thing.
That's okay. The 3D printing, was that all just plastic, or were you using metal filled and fibre filled materials?
No, we only had plastic filament on QE. I don't know what Defender had, but I'm pretty sure they only had plastic as well. I think it was more being used as a sort of fact-finding capability, sort of, not so much demonstration, but a trial, ready for sort of identifying whether it could be done, what shortfalls there were, and then so that we invest in the right kit a bit later on. The problem is that it's a capability that no one really owns. So is it owned by Defence Equipment and Support, or is it owned by Navy? We don't know. So that's one for the seniors to argue about.
Just to go on that, so there's
sorry, I can fill in the gaps a little bit. So the current trial and capability that the Navy owns is limited to plastics. There is a trial plan that we're looking to get started this year, where we're actually taking a metal printing capability developed by the Australians, has been used with the Australian forces, and to try it in this country. That trial's going to look to do some work with us here, consulting, to manufacture components which we can then use to do some testing on and compare them to the original items, and also then to deploy that capability to see how it performs in the maritime environment. The biggest challenge, I think, I'm sure my colleague here would agree, manufacturing components on complex and pressurised systems is a challenge, because for two reasons. One, the IPR for the components you're manufacturing are not owned necessarily by the RN, and therefore you run into a challenge of actually being able to manufacture those components and fit them to systems. And then the other thing is the justifications against those systems. So the safety cases that we operate under are going to a manufactured solution which is done in-house, which hasn't got the engineering pedigree behind it to underpin the reliability, is a challenge. So there's a couple of key areas. We recognise the flexibility, we recognise the adaptability, and I think that's been absolutely proved. Just making sure we get the functionality right, and also the ability to actually manufacture these components from the outset, so that we can use them legally. We don't open ourselves up to litigation. That's a couple of the key areas where we really need to do that. But the trial that we're looking to do this year, if we can get capability installed, will hopefully go after some of those more complex components.
Thank you very much, Doug. Just a quick one on that. We have some 3D printers here in Southern. It's sort of ad hoc. It's come along and have a look at it. It's sort of used for STEM and people to go and have a play with effectively. Did you see training on 3D printers as a real limitation, what you could sort of manufacture on board? And secondly, have you got any recommendations and feedback for that? And equally, how did you get that training? How did you get around the design and production of 3D printed material on board?
Yeah, so I'm ashamed to say that I didn't have a clue about 3D printing when I first got on board. Never touched it. I did AutoCAD at uni and then ditched all that knowledge. So all the training was done ad hoc in-house. So one of our air engineers, she played about with it, got some open source software, and just kept playing with it because let's face it, air engineers don't do much. So what she learned, she then passed on to us, to the stokers. It took a while because we're a bit solid. But yeah, it was all done ad hoc with a personal laptop. Again, bit of a no-no, but we got a 3D printer and no laptop. So we were using personal laptop, open source software, and having a go. So I definitely think there needs to be some training done here if it's going to be a capability that we take forward. If it's not going to be a capability we take forward, then obviously no training, I guess. I think I can see it being used. It got us out of a couple of sticky situations. It should probably be invested in, and I think it just needs to be identified who we're going to train on board and turn it into a PJT. Most likely will be a 3D printing pre-joining training for 1 or 2 individuals, similar to our machinists. We have 2 billets on board for capital ship machinists, one metal worker and one sort of woodworker. It would be a similar capability to that.
Thank you. Just on that one and carrying on from that, challenging, you talked about challenging policy when you were asking, you were going back to Hollywood or whatever, to ask or to challenge them on policy. You obviously had some kickback there. You think you managed to change any of the minds in Hollywood regarding 3D printing? Have you offered anything that suggests that they might get on board with it?
So all our feedback, we have fed it back because I had the privilege of writing the post-deployment report for the ship, and that was thrilling. So we have fed it all back, and I think, unfortunately, those in the shoreside navy, be that DNS or be it MSSP in our case, because it's all subcon to MSSP Babcock, they're all risk averse, but they're also not the ones that don't have any water. I personally don't think that lesson will be learned anytime soon. It was refreshing to see the MEOs across various platforms taking risk, and that risk was always sort of run by our commander ME, the group repair coordinator, who would essentially a second set of eyes to say, yeah, that's an appropriate risk, or to say, for example, with Diamond, you're going alongside and you're getting your gas turbine module changed.
Thank you very much. Any questions?
Alan Cartwright, formerly surface shipment engineer. I'm delighted to hear that you were taking that risk, and the man on the spot was actually kicking us, taking names and fixing the bloody stuff. I left the Navy in 1998. One of my absolute frustrations was that at that time, from about 96 onwards, the Navy itself, not the MOD, but the Navy itself, the Uniform Navy, had decided that people on board ships would just be operators and press buttons and things would happen. And it was down to what was then called the Naval Support Command, DNS, now, to platforms available and fix things so that people could press buttons and make things happen by virtue of contractor support, OEM support. And that started the rot. It continued. I couldn't cope with that. I mean, my last job was senior engineer at Britannia. Now, we had a wonderful saying in Britannia that Britannia waves the rules. So when we had boring bastards, if you'll excuse me, ashore, who weren't trying to make sure that the mess of the Queen could conduct her high-level diplomatic or royal functions, they weren't the ones who were in the forefront in exactly the same way as you were in the forefront of trying to deliver what the government wanted you to do. So we would just go and do what we wanted to do, and we go through risk assessments and so on. We use local contractors, we would use local suppliers, and we'd fix the bloody thing and keep it running. That's a 40-year-old ship. We've got lots of 40-year-old ships. But the Navy went through a period, and I chose to leave because I just could not face this. And at the time, the training, technical training for Sultan and elsewhere, just petered out. And it was, we went through a whole phase where, the amount of time that what would then officers would spend in workshops reduced significantly. Marine engineer officers would not actually go anywhere near the workshops. They'd just do a paper desktop design and make exercise. Ask them to turn a thread. What's that? So it's really, really good that that's coming back. And I think Project Faraday, was it, reintroduced proper skills training. And this deployment has benefited from the recovery of skills that's occurred in the last 5 years. But so that's a big statement. The question is, do you think that your post-operational report is actually going to capture the importance of all these key things that you've identified? The reliance on Royal Naval skills, appropriate Royal Naval skills training, and also the making sure that the equipment and bits and pieces are actually available and not just being cut out by some DNES manager who wants to get himself promoted?
Yes. So what I've noticed over the last 2 months, I think, is that all the lessons that we raised were captured in a system called DLIMS, and because I was sort of the author for the marine engineering department, they're all under my name, which means I get 1,000 emails a day from people who are now following up on these DLIMS, which is the Defence Lessons Identified Management System, Defence Lesson acronym. So I have a degree of confidence that some of the lessons identified will actually be learned and addressed, and some of the issues addressed. An example is our capital ships machinist course, which got cancelled for various reasons, COVID, not enough people in the Navy. We didn't have one. We're now looking to get a second course this year. We're only scaled for one. So an in-year change request to get a second one so that we can actually have machinists who are qualified that know how to use all the wonderful equipment we have on the Queen Elizabeth. And so we can not only support ourselves, but the wider task group. So the skill at hand thing, as an example of just one of those lessons, I think is being learnt and it is being addressed. What was the other question?
Well, within DNES, they have actually voiced it in. They've got to have it as their favourite. And actually, I thought on the showers thing, why are all these showers failing? Because obviously they're designed for it. So let's improve the kit so that they don't fail.
Yeah. So fortunately, my commander, ME, Commander Chatterjee, his next job is Platform Chief Engineer for QEC at DNS. So I'd like to think he goes in with a bit of clout, and having lived this world of pain of not having the stores and parts available, that he'll try and address those. I know that he's going to be hamstrung by contracts. That's the long and short of it. The contract says no, so you can't have it. But I'd like to think that he will at least try and influence spares availability, because I know how frustrated he was, as we all were, when we couldn't do things that we knew we could do if we had the right bit on the shelf. Why were the showers failing? So QE's ships company is about 500-ish, but we had 1,600 people on board. So a lot of the cabins, most of the time, aren't used. They're allowed to degrade over time. Pumpy water is pretty hard. So that seems to be the reason they failed. Why we had to go to Screwfix and buy them with a credit card, I'll never know. But the system failed, and we proved it, and we use that as an example all the time. Going back to our skill at hand thing, I thought of another example. I remember walking into Guam, Air Conditioning Limited, and we bought most of the copper pipe work that they had, and just fixed our own fridges. Fortunately, we had someone who was trained as a HVAC engineer before he joined the Navy, who was all over brazing, patched us up, and we were good to go. and those fridges are still running now. They're due to be, all that pipe work's due to be cut out and changed and valves changed, but that got us out of a real bad situation where, again, we wouldn't have had all those snorkers to eat if we hadn't have just done it ourselves, gone out with a credit card, bought that copper pipe work and done the brazing.
Any more questions?
Yeah, well, thank you. You mentioned the pyro plant a couple of times. Can you just explain what that is?
So QE has an incredibly complicated waste management system. It's called integrated waste management system, but it's not quite integrated. We have pyrolysis plants, which are designed to not burn, but pyrolyze everything pretty much in terms of waste that we produce, be that human waste, plastics, cardboard, medical waste, you name it. We should be able to stick it through the pyro. It burns at something unreal, like 400, 500 degrees C in a vacuum. The vacuum bit is quite often the problem. We have to maintain that vacuum and it's pretty difficult to do. So we find gaskets fail quite often. We find air leaks get in, and once air gets into that 400, 500 degree compartment, we get big issues. Generally fire and smoke, which are bad.
Thank you.
I've just picked up from obviously with a training establishment here. Commander Emily is the head of the DSRE, and there was quite a few things that cropped up there regarding training. There was one or two things. Was the COVID? Do you see COVID or that interlude where personnel weren't being trained and then sent out into the fleet? Do you see that as being a disruption not only to, well, certainly to your marine engineering department? Do you think there'll be a legacy of some people who, sort of through their naval career, never having really grasped basic engineering concepts? I think you mentioned at one point about you have to go back to basics. You know, some unique issues. You went right back to basics, getting the books out, looking at thermodynamics and all that sort of stuff. Were you confident in your department to be able to overcome with that skills gap that existed in it? And I know you got to the end of it, you're obviously back here. But what was your thoughts on what happened, and do you think there'll be a legacy of?
So I don't think there'll be a legacy. I think we are catching up our people. They're catching up missed modules. They are, those ETs that missed out on stuff in their phase 2 will catch up on LETQC. So I don't think that will have a long-term impact. In terms of the fundamentals, I think, but we've got a department, fortunately, of 196. Well, we should have a department of 196 complement. We'd normally sit about 170. So within that group of people, there's a huge amount of brain power, huge amount of knowledge. There's people that have done master's degrees in nuclear physics, and why they're a skipper, I'll never know. But between us and working as a team, we should be able to solve pretty much every problem we have on board. We're all professional engineers, and our job is to engineer solutions to problems by applying some science. And that's what we did. We did that a lot for the pyros because the books of reference don't exist, the training didn't exist. We're now informing that training, so what we've learned, our IWMS maintainers have come back to Salt and informed the pilot course so that the next iteration coming through know what they're doing. So I think, engineering fundamentals and understanding the principles of not only how stuff works, but why stuff works is something that personally I teach in the SCC every time I'm on watch. Is we'll do the fridge cycle over and over and over again, and we learn that when you squeeze things, they get hot, because that is important and will potentially get you out of that sticky situation when that technical document doesn't have the solution in it.
You're almost saying we can do that, so that's what you're saying, isn't it?
You're twisting my words, but
absolutely, yeah. Are there any more questions on anything that Chris has commented on this evening? Yes.
Sorry, hold on. Can I just grab you? Changing tax, I know this is not your area of expertise, but
What did the crew think about the F-35s? Is that something that you that was percolated amongst the crew?
I think the first time people see it, they're pretty sort of in awe, and it's quite exciting and cool. Over 7 months of deck pounding every day, it kind of becomes day-to-day business and almost becomes an embuggerance because they're using up the flight deck, and that's where I want to go for a run and get some fresh air. Generally speaking, the feedback, from the pilots and the guys in the wardroom was they're actually flying it and operating it. It's an amazing bit of kit. From a marine engineer stoker point of view, they're a pain in the arse because I can't get on the flight deck. So, yeah, a great bit of kit, but there's consequences to using that piece of kit, especially if you're using it 365, 24/7. It means that the routines are harsh. It means you can't get sunlight. It means that we have to have, for example, marine engineers closed up to fuel the aircraft, to operate aircraft lifts, and to watch keep on all those pieces of equipment. If they weren't there, I'd have a lot more people available to do the maintain, diagnose and repair bit and focus less on operate. But without an F-35, we don't have an aircraft carrier, and then I don't have a job. So it swings and roundabouts. It's a compromise, I think. But generally speaking, yeah, the feedback on the F-35 is that it's very cool, except for the one that we don't have anymore.
So the enormously complicated feedback from your colleagues who were tasked with maintaining it. Is that generally fairly good with the flying?
Similar to the ship, really. They were quite reliant on, I think more so than us, on OEM support. So the USMC squadron brought with them a guy full-time from, I think it's GE, does their engines, or I think it's GE, and he was essentially part of ship's company for 7 months. So civilian maintainer, and they weren't able to do anything without his sign-off on the engines. And he just, he worked as if he was a uniformed service person. So I think they're even more reliant than us on OEM support.
It's encouraging though that an aircraft that was very troublesome in its development has turned out quite satisfactory from what you're saying.
Yeah, to the point where actually sometimes it was the marine engineering department letting down the air department because, for example, we couldn't move the aircraft lifts because they were broken. Whereas where they had jets ready to go, but they were stuck in the hangar and we couldn't get them up to the lift. Equally, they had their moments where they were entirely unreliable, and we sort of rejoiced because we could get some fresh air and some deck time. We did an awful lot of flying. We did, I think, more flying than Heathrow Airport was doing at the time, which I think speaks to their reliability. There was never a day that I can really remember where it was the jets that would let down entirely achieving whatever objective there was for that day or for that area.
Thank you. Any more for anyone? I've got one last question. Was that anyone? No. Naval stores. Okay. Anyone who's sort of, even Alan mentioned it earlier on, naval stores are the bane of most Samandas and general service and Royal Naval personnel's life. We've never really been able to address or provide a system that works at reach. You identified a really important but realistic concern where we currently sit in the world at the moment. We're talking about Achillean, going out to reach again, and where we are just now, and what you might be called to do in the future. Who knows how the world is going to be in the next couple of months, never mind next year or two. It's all good in peacetime that you can get bits of kit thrown out to you, you can get that valuable item out to you. Do you think in the future, if we were in a wartime situation, do you think we would have that support and that availability to you Are you confident you would get it? And was there any, and sorry, just one last question on the end of that there. Was there any points in your deployment where you thought you were not going to be able to do it?
I think it takes you back to the lessons I identified. Is now that we've done this deployment, we have to learn the lesson of what we use, what's vulnerable, what breaks, and then stock it. And that needs to be on Fort Vic or whatever support vessels we have. I think that's vital. You know, we were eating through fuel pumps, and they're not small, cheap, or necessarily readily available. We're getting so bad that we were running out of sort of the global supply of Wärtsilä fuel pumps for that particular engine, and Wärtsilä is a huge company. So yeah, I think the most important thing we can do is look at properly and analyse properly what we're using, where we're using it, understand failure modes, and then stock the right parts and also the laptop, so that we can then do this organically and not be reliant on the Rolls-Royce engineer to come out or the Wärtsilä engineer to come out and set up a governor. That's something that we should be able to do. The only reason we can't is because of a lack of laptop.
Yeah, it's crazy that
So-
we've got these facilities here, in training diesels, and yet that can stop the sort of entire deployment. And was there ever a moment you thought you're not going to be able to?
Yeah, it was the fuel pump. So it was the individual fuel pumps for each cylinder. Over time, they were just with that much moisture where we were operating, we weren't able to remove as much moisture from the fuel as it was sort of generating. Like, it was genuinely raining in the engine rooms out of the engines. There was that much condensation, and we were getting to the point where we weren't able to get any more fuel pump assemblies. So we were then on to the point of just getting refurb kits, as many of them as we could get our hands on. Fortunately, with ship design as it is and IEP as it is, we had 2 gas turbines, which obviously didn't suffer from that failure, and we were essentially did most of the trip with one of the engines out of action, and that was Rob and Peter to pay Paul. So we had a spares barge in one of our diesels. If we'd have carried on, if we hadn't have managed to get as many fuel pumps as we did, I think, yeah, we would have been certainly below the guidance on what was safe to sail, and we would have had to take it on risk and sort of go home on gas turbines all the way and drink a lot of fuel.
Thank you very much for answering that. I think, is that as done with the questions? No more? Okay, ladies and gentlemen, Sir Mallons, I'd like to thank Chris for his insightful lecture on the Carrier Strike Group 21. If you'd like to put your hands together for Chris, thank you very much.